Today I'm going to talk about the challenges and advantages of using citizen scientists for environmental monitoring. This is the first of a series of seminars that we're going to produce as part of the Mid-Atlantic Tributary Assessment Coalition. Our goal is to provide concise, thought-provoking ideas relating to Mid-Atlantic environmental assessments. The rules of engagement are that we're going to do a maximum of 10 or 15 minute video talks, which we capture and post on the Integration and Application Network website. And these videos are released under a Creative Commons license so they can be freely shared and reposted. To start with, effective monitoring requires a significant investment of resources. Field work is very expensive. It takes people, vehicles, equipment, and boats to get out and collect samples. Once you've collected the samples, data analysis is also very time and resource intensive. We need to develop databases and maintain the databases and do statistical analyses. And these costs are all recurrent costs. They don't go away, and they're subject to inflationary pressures. So as a result, we really do need to think about using citizen science to augment monitoring efforts and defray the cost of monitoring. So first of all, what is a citizen scientist? Well, there are a few key words in this definition. One is a volunteer who's trained, and they're trained to collect accurate environmental data that can be integrated, analyzed and integrated into a monitoring program. So it's not just that they're volunteers, but they're trained volunteers collecting accurate data that goes into an integrated program. They're crucial for comprehensive monitoring and protection of watersheds because they can get to the small regions. They can get to local areas that otherwise aren't obtainable by state or federal monitoring programs. They volunteer their program within an organized program with sponsored by the resources from various institutions and agencies that have quality control guidelines to ensure the high quality data collection, storage, and analysis. And the report cards that are produced by the watershed groups in the Mid-Atlantic region wouldn't be possible without the dedication and hard work of these citizen scientists. Advantages of using citizen scientists are that it reduces the disconnect that people have with the natural environment and the agencies that manage those natural environments. So it's a great opportunity to get people outside into the ecosystem, experiencing the ecosystem, looking at it, and observing firsthand. It also empowers those citizens that have been in the ecosystem to come and help shape the local government decisions. If you go to a town hall meeting and you say, I was on the river and I saw this, it has a lot more credibility than anyone else in the room. It also provides a way to inform citizens about the complex issues like climate change or land use alteration that are affecting our waterways. And ultimately, it provides a fresh set of eyes in the ecosystem because they can serve as sentinels. So if they see a fish kill or an algal bloom or something going wrong, an illegal discharge, they can act. They can alert proper authorities and create a follow-up activity. They also can monitor at fine-scale resolution that you wouldn't get otherwise. So the Chesapeake Bay, a very well-studied and monitored bay, has 160-some sites by the integrated monitoring program run through the EPA Chesapeake Bay program and administered by state agencies. And so you can see when you blow up the northern bay, and this is the Chester River watershed here, you can see the Chester only has a few of these sites because of the scale of Chesapeake Bay being 200 miles from top to bottom. And then when you get into detail, these sites by the Bay program are very far and few between. And so the Chester testers, the Chester River Association monitoring sites, can provide a whole level of detail that you wouldn't get otherwise. There are challenges of using citizen scientists, and some of those challenges include data quality assurance issues. So you have trained volunteers, but you don't necessarily have the level of training of the programs run by state agencies. The database maintenance and access to that database becomes an issue. The personnel continuity and turnover. Volunteers come and go, and the turnover and the staff supporting the riverkeeper groups also has turnover. So we need ongoing training and coordination to maintain that continuity. And there's historically a lack of standardization of approaches, techniques, and analyses. And of course, this is the central goal of the MTAC group, is to come up with some standardization and move that into the different groups. What I want to do is break down the process into 8 component phases of doing an eco-health report card using citizen scientists. Now I'm going to start in this fashion and work around the circle. Start with interactive partner building, go into, and these inputs involve money and time, resources from agencies and foundations. Then interactive training modules, citizen science data stream, interactive quality assurance, interactive visualization of the data, finally producing the report cards, and creating environmental literacy, and then finally evaluation and dissemination. So this process I'll break down and go through these one by one. And all of these on the top have an ongoing needs assessment, what do people need, and this part has an ongoing evaluation and enhancement. So it's important to have feedback throughout the process. Start with interactive partner building. And that's the important issue here, is to establish, maintain, and foster partnerships that can leverage resources, can widely disseminate results, and enhance the environmental literacy of the public. And it's important to start by building on existing partnerships, but then go through a rigorous ongoing needs assessment to prioritize new partners to be developed, evaluate your existing partnerships, and learn how to enhance this process so that we build from what we know. Next, I'd like to group 4 of these modules, these components, into what we would call a desired data interface. These are attributes of a database that we would like to see. This is our vision. We've called this vision Eco Hub. And the idea here is that we should try to create interactive training modules so we can have online video introductions, interactive environmental activity, a step-by-step web tutorial. We can test the learning through quizzes online, and the module evaluation by the trainee can help make those training modules more effective. So that would be a fantastic tool to have. Another tool would be to have a smartphone app with the web interface so that the citizen scientists can be on site enhancing their outdoor experience and accessing photos and data and uploading photos and data from the site. Review the monitoring instructions, upload photos and video clips, look at the georeferenced photos, streaming the data from the field, and look at remote sensing imagery. Another component to this data interface would be an interactive quality assurance, and that would be a data filter, so some trigger points. So if you plug in, upload data that says you have oxygen levels that are outside the normal range, it triggers an alarm, and you go back and reevaluate, maybe go back and look at your training module and see, maybe I didn't do the sensor, handle the sensor, or read it correctly. And then it could set up an alert to alert other people that something wonky's going on. You can have an Ask an Expert. You can have online field guides like the Chesapeake Bay Trust has produced for some of the species, and links to image libraries so you can access different images. And then this interactive data archive could have time, location, georeferenced images, and comparison with past data. So you can get a handle on, are your data appropriate? Finally, the interactive data visualization. The concept here is provide different scales of visualization, a temporal scale. So you can automatically add a data point and see how that's tracked to recent data collected. Spatially, if you've got, again, a low oxygen or high oxygen event, and you can immediately look and compare from the Chester River, well, did the Patuxent have that? Did the Severn? You can look at other systems. And conceptually, automatically diagram systems with your symbols that are developed from the data that you've uploaded. And then there are all kinds of interactive visualizations you could do on the spheres, on flat surfaces. So, you know, we could envision nowadays with the technology of smartphones, we could have this hub, and we could access your location, georeferenced location. You could ask it to enter data, or you could submit your reports. You can produce a data, actual numerical data. You could produce a graph. You could produce a map. and a diagram. So this smartphone app concept would be a really good way to enhance, use the new technology to enhance the experience the citizen scientists have when they're out sampling. But the whole reason for doing these is to integrate them into these EcoHealth report cards. This is the central feature of the Mid-Atlantic Tributary Assessment Coalition. And the health of the ecosystem needs to be defined by the stakeholder values, the things they care about: clean water, fishable, swimmable, etc. These values can be matched with various indicators and thresholds. The EcoHealth report cards generated by combining these indicators into integrated indices for the different reporting region. And then the interpretation of this data is woven into a dissemination strategy that's implemented by the riverkeeper groups. And the idea is that this is a step in creating environmental literacy. And what I mean by environmental literacy is providing a suite of well thought out literacy principles that focus on the unique features of a region, the major processes and key threats, the diversity of biota and the habitats, and the human dimensions that influence the ecology. And it's important that we learn about the environment so that we can take that knowledge and act upon it, including the willingness to implement strategies that will improve the ecosystem health. Let me give you an example at the broad scale, and that's the scale of Chesapeake Bay, of seven environmental literacy principles for Chesapeake Bay. First is Chesapeake Bay is a large, shallow, productive estuary formed by a drowned river valley, Susquehanna River Valley in particular. The extensive Chesapeake Bay watershed is connected to the bay by a myriad of streams and rivers. It's particularly vulnerable to runoff of nutrients, sediments, and toxicants, and you can see the urban footprint along the fall line here of the major cities. We can see the major agricultural footprint on the Piedmont and coastal plain of the watershed. Climate change and land use alteration are major drivers for Chesapeake Bay and its watershed. Chesapeake Bay supports unique human cultures and livelihoods. The watermen historically on Chesapeake Bay and the villages and fishing villages and family farms of the region. American history has been shaped by Chesapeake Bay. The Revolutionary War, the War of 1812, the Star-Spangled Banner was written on Chesapeake Bay, literally, and the Civil War. Chesapeake Bay has been extremely well studied and intensely managed. So these are the kinds of principles that we could create for each region that focuses on the unique features and the important processes that occur in all the different areas. And then evaluation and dissemination. So the importance here is to learn by doing, to evaluate how you've done it, look at the level of public engagement, how many citizen scientists, how many people read and interpreted the report card, how is that translated into different actions? Have we increased our literacy, environmental literacy? Do we have some kind of interactive evaluation process so we can continue to collect data about how well we're doing on that front? The dissemination includes media events, the report cards themselves, and the supporting web materials. So the idea here is if we get these citizen science data streams, we can produce web materials, we can produce perhaps a smartphone app, but we definitely can produce at the core of these report cards. And then there's a whole suite of things that we could use to leverage from that. We could use the social networking, we could use formal and informal educators, we can use museums and aquaria, conferences, we can produce scientific publications. So there's a whole range of materials that can stem from this effort. So, to conclude, we need ongoing support for citizen science. We need to develop swimmable indicators. Is the water safe to swim in? We need to develop fishable indicators. Is the fish safe to consume? We need to create training programs and manuals. We need to empower more catchment groups so we have a broader coverage. And I think if we use this technique of picking off the components of what goes into developing a good ecosystem health report card process, good evaluation, good dissemination, develop better literacy, develop the tools and techniques, we can achieve this and more based on the coalition that's formed from MTAC. So I'd like to acknowledge the Mid-Atlantic Tributary Assessment Coalition, the Integration Application Network, and the Chesapeake Bay Trust. Thank you.